Okay, what I'm going over now is the support for 7.4. So it's this assignment right here. That we are going to talk about, and it's on quadratic functions and solving quadratic equations. Okay, and we're going to talk about 3 different ways to solve the quadratic equations. And quadratic equations have they all have 2 answers. Okay, we're going to do 3 different methods. We're going to solve some by factoring. We'll look at some that are best solved by the square root property, and then we will look at some that are best solved by the quadratic equation. But then we're going to talk about the quad program on your calculator, okay? And if you don't have the quad program on your calculator, you'll probably want to get it before you do this section. So hopefully we'll be on campus Wednesday. I don't see why we wouldn't. I think the reason that we're closed today is some side streets are still kind of messed up, and I think there's a couple of buildings on campus that don't have water, maybe from busted pipes or something. So I can give it to you. I can link our calculators together, or the people that are in the tutoring lab that is in the campus center building, which is where our classroom is, right across the hall. I think in room like 310 maybe is the math tutoring. And they all know in there that anybody that's one of my students that comes in there and asks for the quad program on their calculator, that they can give it to you. So that way, if our times don't match up, you can just go see them and they can link their calculator to yours to give you the quad program. Okay, but for now, we're going to do these 3 different methods. And then I'm also going to show you how much easier they can be solved with the quad program on your calculator. Okay, so again, we're going to do factoring, square root property, and then the quadratic equation. Okay, the first problem is just going to say to solve. Okay, and you've got a problem that looks like this. Okay, this method will lead us into solving by factoring. It's just that this first problem, it's already in its factored form. Instead of having an s squared, where you do have to do the factoring on your own, it's already in its factored form, which means if it's already in its factored form with a 0 on the other side, you just take each one of these factors, so 11s plus 6, and set it equal to 0. And then the other one, which is 5s minus 15, and set it equal to 0. And then solve each of these 2 equations to get your 2 answers. So we'll solve this one first. So getting this s by itself, we would have to get rid of this plus 6 with a minus 6. So now we have 11s equals negative 6, and then divide both sides by the 11, which would give us s equals, and then that's just a fraction that doesn't reduce. So one of your answers is just negative 6 over 11. And then the other one, get rid of the minus 15 with a plus 15 to both sides. So now you have 5s equals 15. And then divide both sides by 5 to get s equals, this one does divide, 15 divided by 5 gives you 3. So your two answers would be -6/11 and +3. So the way you would enter that is just the -6/11, comma, 3 are your two answers to this equation. Okay, when we get to number 2, okay, and it'll just say solve, and your easiest method is the factoring method. Okay, the quadratic formula, which we're going to look at in a little bit, will actually solve all of the quadratic equations or all of the squared equations. But if your equation does factor, then that is the easier method. So what you're going to do is factor this, right, to make it look like the last one where you have the two factors in their parentheses. Okay, so let's make our two parentheses. And we're going to break this apart into its factors. So remember, we did some of these, it feels like forever ago, before the snow break, where these two parentheses have to FOIL or multiply together to give us this r squared minus 5r minus 36. These first two terms of the parentheses have to multiply to give us this r squared. Okay, now this one's not as bad because there's only one way to get r squared. It's going to be r times r. Now the last two terms in your parentheses have to do two things. They have to multiply to equal that end number, which is -36. But they also have to add to equal this middle number, which is -5. Okay, so let's talk about all the ways. Don't worry about it being negative yet. Let's just list all the ways to multiply to get 36. And I'll just do that over here. 36 times 1. Let's see, it's even, which means 2 goes into it. 18 times 2. Another way would be 12 times 3, 9 times 4, and 6 times 6. So there's several ways to multiply to get 36. What we have to do is come up with the pair that does both of these things for us. Now, what I do know about a negative number right here, if I'm multiplying to equal any kind of negative, I'm going to have different signs, right? I'm going to have a positive number and a negative number. Okay, so we know that on the front end since we're multiplying to -36. So one of these numbers of the pair that we're going to choose will have to be a positive, and the other one's going to have to be a negative. So what the pair is also going to have to add to -5. So let's think about this. We can probably cross off some of the pairs right off the bat, because no matter what I do with my signs, I'm not ever going to get a 36 and 1 to add to a -5, no matter what I do with my sign. So I know it's not going to be 36 and 1. It's not going to be 18 and 2, right? You're not going to be able to get a -5 from that. 12 and 3, I'm getting closer, but I still can't make a 12 and a 3 add to a -5. But what about 9 and 4? Okay, so sometimes it's easier to come up with the pair. I think it's going to be this pair because I can use my signs to somehow make 9 and 4 be -5. Okay, but since the signs are different, I do have to be careful where I put each one of these numbers. So let's see, what's going to be -5? Who needs to be the negative number in this pair in order to add to -5? Well, if I'm going to end up negative, I'm going to have more negative. If I'm going to end up on the negative side, which means the 9 needs to be negative and the 4 needs to be positive. So let's check. Does it do the two things I need it to do? Does it multiply to -36? And it does, right? Because -9 times +4 does equal -36. And if I add them together, -9 plus 4 does add to -5. So this is where you have to put your numbers with these signs. The 9 needs to go with the negative, and the 4 needs to go with the positive. Okay, so now I have my factors. And after you do the factoring, now we're to the step like we were on problem number 1. Once you have the parenthesis factors, you set each one of them equal to 0. And then solve them. So this r plus 4 equals 0. I need to get rid of the plus 4 with a -4. So here r equals -4. And then here, this -9, I need to get rid of that -9 with a +9 to cancel that. So here I'm left with r equals 0 plus 9 is +9. So your two answers are -4 and +9. Now, let me show you what the quad program in your calculator does for you. So if you have the quad program, which you probably don't unless you've put it on your calculator, if you'll see this program button, PRGM, if you hit that, I've got a bunch of different programs. So I would go down to the one that says quad. Okay, so I'm on quad. And I hit enter. So it's asking me, do I want to run the quad program? So I hit enter again. It's going to ask you three things. It's going to ask you what's your A, what's your B, and what's your C to run the quad program. Well, your A, coming back up here to the original problem, is the number in front of this squared term, or that r squared. The number in front of it, since I don't see a number, is automatically a 1. Then it's going to ask you what your B is, which is the number in front of the R, which is with its sign, -5. And then your C number, which is the constant, which is just this last number out here that doesn't have a letter hooked onto it, which is -36. Okay, so let's put that in our quad program. Again, it's going to ask me what my A is. So I'll just tell it 1 and hit enter. Then it's going to ask me what my B is, which was -5. So I'll type in -5 and hit enter. And then it's going to ask me what my C is, which is -36. Now watch what happens when I hit enter. It tells me the two solutions, 9 and -4, which is what I got when I worked out the whole problem. So that's why this quad program is going to be very beneficial for you for this section and the 7.4 section that we're doing later. Okay, so let's look at number 3. I've got 3x squared plus 16x plus 20. Equals 0, okay? Now, the first thing you want to do if you're using your quad program is to make sure that you have a 0 on one side of the equal sign, okay? And then again, here's your A, your B, and your C. This is a much more difficult factoring problem, okay? But again, if you use the quad program, again, program, down to quad, and enter your A, B, and C, which are 3. My B looks like 16. And my C is 20. And hit enter. Now, the program that I have, and the one that you could get from me or in the tutoring lab, you'll have to enter twice, especially if you have a decimal, because Math Lab's not going to have a decimal answer. So all you have to do again is just hit enter again. Okay, and what it does is it gives you the two answers, -2 and -10/3. For your two answers. Okay, so you may want to hold off on doing this section's homework for sure until you get this program on your calculator. Okay, let's look at number 4 and we'll talk about the second kind of method other than factoring, which was the square root property. Again, this can be solved in your quad program, but I'm just going to show you a square root property worked out. When you're using the square root property, you use it on problems, first of all, that don't factor. If I tried to factor this, I wouldn't be able to solve it because it's not factorable. After you take out the 3, there's nothing else that you can do to simplify this. So this is a good method for what's called the square root property. When you're using the square root property, you don't want the 0 on one side. You want the x squared to be by itself. Okay, so let's get the x squared by itself first. So if I'm getting x squared by itself, I need to get rid of the -39 with a +39. So now I have 3x squared equals, on the right side, I have a 39. I can still remove something to get this x squared by itself. I'm going to divide both sides by that 3 that is hooked on. So now x squared equals 39 divided by 3, which is 13. Once I get the x squared by itself, remember how you go from x squared to x. To get rid of that square, the opposite of it is the square root symbol. That's why it's called the square root property. If I do it to that side, I have to do it to the other side. Right? Because I'm trying to figure out what x equals. So the square root knocks out the squared. So all I'm left with is x equals. Now, here's where your two answers come into play. When you take the square root of the right side, you get the positive and the negative of whatever that answer is. Okay, so I'm going to actually get, when you take the square root of the right, that's when you're going to get the positive and negative of whatever this is. So since it's the square root of 13, I can't simplify that, right? It's not like the square root of 9 that I can turn into 3, or the square root of 16 where I can turn into 4. Okay, it's the square root of 13, which doesn't simplify, which means that's just as far as you can take that. So the answers are positive square root of 13 and negative square root of 13. Okay, so let me show you how you would put this one into the quad program, because remember the quad program is going to ask you three things. It's going to ask you what's A, what's B, and what's C. Well, when I'm looking here, I only see two numbers in my original problem. Okay, so remember when we were doing the one before this, the A is the number that's in front of your squared term. So your A is going to be 3. Your B is the number that's in front of the X. So when I'm looking here, it's like I have a missing term in the middle of these two, right? There's not an X term, which means your B is going to be 0. This is your C. Right? The C is the constant, which is the number that doesn't have a letter hooked onto it. So if this is my C is negative 39. So again, my A will be this 3. My B would be 0 because it's just missing. And my C is the constant, which is negative 39. So let me show you how this works. So again, if you go to your quad program, so program, down to quad again. Your A was 3. Your B, you would have to put in 0 because you have to put in something for all of them. And then your C is negative 39. Again, it gives me some kind of crazy decimal. So when I hit enter again, here's my two answers, 0 plus the square root of 13 and 0 minus the square root of 13, which is the same thing as 0. This is 0 plus the square root of 13, and that one's the minus square root of 13. So those are your two answers. Okay, number 5 is the same kind of problem. For x squared equals 52. So again, another good problem to use square root property. So to get x squared by itself, I would just divide both sides by that 4. Oops. So again, there's my x squared, 52. Divided by 4 gives me 13 again. And remember, to get from x squared to x, now is when I square root both sides to knock out the squared. So there is my x equals, again, I can't simplify this because it doesn't simplify. But I do get my two answers. Remember, when you're using the square root property, when you take the square root of the right side, that's when you get your positive and negative. And since I can't simplify the square root of 13, it stays just like that. All right, I'm going to put 7 and 8 up here together. And to show you, if you didn't have the program, again, if you have the program, it solves all these problems. If you didn't have the program, when you would choose to use factoring compared to the square root property. Okay, and again, the best examples to show this are on number 7 and number 8. Okay, here's the difference between 7 and 8. On number 7, you have a squared term and a constant, just like the last two problems. We didn't have an X term. That's a good candidate for the square root property. This one, you'll notice you have a squared term and an A. You do have the A. What you're missing is the constant. So this is one that I'm going to use the factoring method. So let's look at the difference between these two. And again, the quad program is going to do all of these for you. So if I'm doing this one and using the square root property for number 7, that would mean to get the x squared by itself, which would mean to subtract 9 from both sides. So now I have x squared equals negative 9. Once the x squared is by itself, then you take the square root of each of these to knock out the squared. So x equals, now remember, when you take the square root of the right side, again, that's when your positive and negative answer comes in. Now, here's something that we haven't seen before. Square root of negative 9. Now, first of all, 9 is a perfect square because the square root of 9 is 3, but it's negative 9. So this takes into account, this brings up something new called imaginary numbers, okay? If you're taking the square root of a negative number, your answer is just going to have what's called an I in it. So instead of it just being positive and negative 3, it's going to be positive and negative 3I. So your answers, if you typed them in, would be 3I and negative 3I. Again, if you have the program, quad. So your A, which would be the number in front of x squared, which would be a 1. Your B, remember, you don't have an X. The X is what is missing. So that's what's going to be your 0. Your C is the constant, which is positive 9. And then you hit enter. So you'll notice these zeros are kind of nothing. So you have positive 3I and negative 3I as your two answers. Now, this other one, I'm going to use the factoring method like we did on the first couple of problems because it's got an A squared and an A term. If you're factoring, you do want it set equal to 0, which means the first thing I need to do is move the 35A over here. So I'm going to subtract 35A from both sides. So on the left, I have 5A squared minus 35A equals 0. Now here, you'll notice I have an A squared and an A term. So that's different than just having the constant. So if I was using, we'll do the program in just a minute, but I'm going to try to use factoring to solve this. So since there's only two terms, I'm looking for what's in common with these two terms to factor this. Okay, so if I'm going to factor this, 5 goes into both of them, and they both have an A. So you can pull out a 5A and then put in parentheses what is left. So if I pull out the 5A and put in parentheses what is left, so which means you would divide these. That's how you find out what is left. So if I'm dividing this by 5A, and you can kind of write that out if you want. That's how you see what's left. So if I took out the 5 and I took out an A from the A squared, I would just be left with an A minus, if I divided 35A by 5A, I'm just left with 7. So remember in the factoring method, once you have your two factors done, You set them each equal to 0. And then solve them for the A's to get your 2 answers. So on this first one, I would divide both sides by 5 to get rid of the 5. So A equals 0 divided by 5 is still 0. So that's one of your answers. To get rid of minus 7, I would have to add 7 to both sides. So here I'd be left with A equals 0 plus 7 is 7. So your 2 answers would be 0 and 7. So let's see how we would put that into the quad program. So again, I would go to quad. So program, down to quad. And enter my A. So remember, before you do the quad program, it does have to be set equal to 0 so that your A, B, and C will have the right signs. So you're using this right here after you set it equal to 0. So A, your A is the number in front of A squared, so it will be 5. This time I do have a B, right? The missing term is the constant. That's what's going to be your 0. I don't have a plain number without a letter. So my B, which would be this number right here, is negative 35. My C is what would be 0 because I don't have a constant. Uh-oh. That error? Oh, I put in 25. I put in the wrong number for B. Whew. Did y'all see me do that? So A is 5. B is negative 35. And I think I put in negative 25 last time. And my C is 0. So there's your 2 answers. So again, if this hasn't convinced you that the quad program does wonders for you, then I'm not sure. All right, number 9. All right, let's try number 9. 5y to the third. So this is something new. Minus 34y squared. Minus 7y equals 0. Now, remember, the quad program is for squared equations. This one's a cubed equation. But sometimes there's things that we can do to our problem that will turn it into a squared equation. If you're looking at all 3 of these terms, what do all 3 of them have? They all have a y, which means you can pull that y out. If I pull the y out and put in parentheses what's left, which means I'm going to divide them all by y, which essentially just means they're all going to lose a y. So what does that turn this into? If it loses a y, now it's 5y squared. If this one loses a y, it's just going to be minus 34y. If this one loses its y, it's going to end up just being minus 7. Now, one thing I should have said before we did that was this is actually going to have 3 answers because it's a y to the third problem instead of a y to the second problem. So what I'm going to do, this y is what's going to give me my first answer. I just set it equal to 0 and solve it, which it's already solved once you set it equal to 0. So one of your answers is going to be 0. Now, look what you have here. This is going to give you your other two answers. And now it is a squared problem that I can take to my quad program. So that's what I'll do with what's left here, is go to program, down to quad, and enter your A, B, and C. So now my A is 5. My B is negative 34. And my C is negative 7. When I hit enter, I get a decimal, just hit enter again. So your answers are 7 and negative 1/5. So the ones that came out of here were 7 and negative 1/5. So your three answers are the 0, the 7, and the negative 1/5. Okay, so we're going to go to number 11 and 12. Which are graphs. So what we've been dealing with are quad equations that have two solutions. Now remember, if you were graphing these problems, since they were all squared, except for that last one, but they were all squared, they would make U shapes. The solutions that you are getting when you are solving these equations are their X-intercepts. So on number 11, I should have put my glasses on. You actually have a picture instead of the equation. So if I would have put, for instance, if I would have put number 3 into my y equals and told it to graph it, remember what the answers were to number 3. They were negative 10/3 and negative 2. That would have been where that parabola crossed through the x-axis. That's what you're finding when you're finding the two solutions, is where, if I graph that parabola, where would it cross through the x-axis? Okay, so instead of, on number 11, instead of it giving us the equation, it just gives me this picture, and it asks me two things. It says the x-intercepts are blank, the zeros are blank. Well, your x-intercepts are points. This point and this point. You want to type those both in as ordered pairs, right? Because all points are ordered pairs. So this one, it doesn't matter which one you do first. Its x-intercept is at negative 2. The y would be a 0. Right? Because if you're on the x-axis, it's because your y coordinate is a 0 because you haven't gone up or down at all. The other x-intercept is this one, which is at positive 3, 0. So those are your x-intercepts. Then the second part says the zeros are well, your zeros are just like if you would, they're just the solutions, like you would have gotten into all the other problems. So your two solutions would be negative 2 and 3. Now you do not put that in parentheses because you're not naming a point here like you are in these two. Those are naming those two specific points. When you're calling the zeros, it's just these two numbers right here, not in parentheses because it's not an ordered pair. Those are just the two answers that you have. All right, number 12. It's the same kind of problem. It gives you a picture and it asks you what the x-intercepts are and then what the zeros are. Okay, this one's a parabola too, but it's upside down. And again, it wants to know what are the x-intercepts. So those are naming those 2 points where this parabola crosses through the x-axis. So this one would be at -3, 0. The other one crosses through at +5, 0. So those will be the x-intercepts, and then the zeros, again, are the solutions, which is just -3 and 5. So a lot of times people use those words interchangeably. The solutions, the zeros, the x-intercepts, they're all talking about the same thing. All right, number 13. Says to use the quadratic formula to solve. Okay, now we aren't going to use the formula. We're going to use the program. So what I want to focus on 13 through the end is how to set up your equations right to use the program. Okay, before you can use the program, your equation has to be set equal to 0. If not, one of your A, B, or C is going to have the wrong sign. So before I can enter any numbers into my program, I have to set it equal to 0, which means move this term over here to the left by subtracting 45 from both sides. So here, I've got the x squared, then the minus 4x, then that minus 45 equals 0. So now I can enter my A, B, and C correctly into the quad program. A would be 1, B would be the -4, and the C, which is a constant, which would be -45. So you notice when I move this 45 across the equal sign, it became -45. So that's what I'm talking about. If you don't set it equal to 0, one of your things that you're entering into the program will have the wrong sign. Okay, so now you're just going to the program and entering your A, B, and C. So A would be 1, B is -4, and C is -45. And hit enter to get your two answers, which are 9 and -5. All right, number 14. Okay, and we only have 5 minutes left. So the last 4 problems, I'm just going to set them up to put into the program to make sure that your A, B, and C are correct. So again, before I would do the A, B, and C, the first thing I would have to do would be to move the 24 over by subtracting 24 from both sides. So there's your 0. on the left, you'd have 6x squared, then the plus 7x, and then the minus 24. So there would be your A, B, and C, which would be 6, 7, and negative 24. Okay? Number 15. Now, this one has something a little bit different. I still need to set it equal to 0, which means the 64z needs to come to the other side. So just like the last one, I need to subtract this off. Now, when I put it on the left, remember your terms need to be in the right order. So this minus 64, when I put it on the left, is actually going to need to be in between these two terms, right? So that my A, B, and C will be in the right order. So when I subtract 64z from this side, I'm actually going to put it in between those two terms. So I would have 16z squared, then the minus 64z, and then the plus 62 equals 0, right? Because this needs to be in the middle. The constant always comes last. So that way, when you do your A, B, and C, they're all in the right order. So your A would be 16, your B would be negative 64, and your C would be 62. All right, number 16. So this one's already set up for us, right? It's already equal to 0. All my terms are in the right order. I have my squared, then my x, then my constant. So they're all in the right order. So you can go ahead and just do your A, B, and C in the program. Your A would be this 1 out here. Your B, which is this number right here, which would be negative 1. And then your C would be that positive 2. All right, last one. All right, so it's not equal to 0, which means I have work to do before I can plug into the program. The minus 9 needs to come over here. So this time, instead of subtracting, since it already is a minus, to get rid of it, I need to add 9. And it's the constant, right? Which means it's going to go at the end. So let's see what we have here. We've got 5x squared plus 6x plus 9 equals 0. So once again, your A, B, and C are 5, 6, and 9. So again, sometime this week, make sure that you do try to make a trip up to campus to either see me and get the program or go to the tutoring lab to get the program before you do this section to save you a ton of time. Okay? All right, I will see y'all on Wednesday, hopefully on campus.
Okay.
All right.
Have a good day.
Thank you. Y'all too.